All right, so good evening. In today's session, we'll be looking at the topic of vectors. Now, what we need to understand is that in mathematics, all quantities has one of two types. Quantities could either be a vector quantity or a scalar quantity. Scalar quantities, and we could access this on a multiple choice. Scalar quantities, they have only size alone. So like age and length and mass. But vector quantities, they have both size and direction. So they have magnitude and direction. So when we look at vectors, these quantities, they have both size or magnitude and direction. Now, normally, when you see a vector, they are normally represented with a straight line with an arrow on it. Right? Basically, the arrow shows the direction and the length of the line represents the size or the length of it. Or in other words, as we're speaking vectors, the magnitude of it. Now, in a vector, we could think of it as the directions or the instructions to get from one location to another location. So let's say I want to get from one point to another point. I'm going to start by explaining it using a graph. Right, so let's say I have a little graph. Right, so this is my y and my x-axis. So let's say I have a graph and it's going like this. Now I want a particular number, so let me just put this in. Right, so let's say we're given this graph, right? And they gave me this point on the graph, and let's call it A. Now the location of this point, remember we normally write our coordinates as the x value and then the y value. So we always put the x value first and then the y value, and we put it together in what we know as our coordinates. Or we call both of them together a point. So these two coordinates, the x coordinate and the y coordinate, comes together to form this point. Now, in order to read our graph, I'm going to look at my A value, my X value of A, right? Remember, anytime you're reading your graph, although my X-axis is horizontal, we read our values for X vertical. So this line here is X is 1. This line here is X is 2. This line here is X is 4, and so on. So A is actually on the line X is 3, right? So the value of X for the point A will be 3. And then for the y value of A, point A, remember, although my y-axis is vertical, we read our y values horizontally. So this is y is 2. This is y is 1. So therefore, A is where y is 4. So the coordinates of point A will be 3, 4. I'm pausing here for a second. Now, this point A is located where x is 3 and y is 4. So this is like the address of that point, right? So when they give us the coordinates of a point, it's like the address. That's where the point resides, so that's where the point is located. Now with a vector tells me the instructions to get to a point, right? So we could think of vectors as the instructions to get to a particular point. Right? That's like in layman terms how to explain it. Now, vectors are usually represented like this. Right? This is known as a column vector. And basically, the X tells us how to move left or right. Right? If X is a negative number, it means yes. Yes. So there's a question if it's like matrices. And if you think about it, it's true. In fact, you're going to see where matrices are going to link with vectors. So that's why I like to go with the vectors first, and then it kind of makes it easier with respect to the matrices. So good observation. Yes, it is. It is a matrix. It's a 2x1 matrix, right? So a column vector is always in this form. Now the top number is going to tell you how to move left or right. If X is a negative number, it means you're moving that number of times to the left. And if it's a positive number, if X is a positive number, it means that you're moving that number of times to the right. The bottom number tells me up or down. If Y is a positive number, it means you're moving that number of times upward. And if it's a negative number, it means you're moving that number of times downward. So it comes like A is located at 3, 4. So that's like the address. But let's say I was given the vector OA. Now the O just simply means that I'm coming from the origin. 0, 0 is your origin, where Y is 0, X is 0. So let's say I had the vector OA. Now, vectors are used with lines and arrows to show the direction in which you're moving. So you could either see it drawn like this, or you might see it written like this, where it shows that you're moving from O to A, and you have the arrow on top to show the direction in which it moves. Now, this is telling me the instruction. So if they ask me from OA, it comes like they want the instructions to get from O to A. Now, to get from O here to A, I'm going to move 1, 2, 3 places to the right. Right, so my X is going to be positive 3, it goes on top. Right, so we're going to move 3 places to the right. And then when we get to here, we're going to move 1, 2, 3, 4 places up. So the instructions to get us from, I just have to undo so that I don't erase everything. So the instructions to get us from O to A will be 3, 4. Again, if it's written like this is like the address. That is where it is located. If it's like this, it's telling me the instructions to get us from one point to another point. I'm going to pause here. All right, so now that we understand the difference between our values written like this, right? Remember, this is like where the point is located. That's its coordinates. This is going to be basically like the instructions to get from O to A. Now notice that the X was the same and the Y was the same. So hence, if they give us a question like this, so like let's say they gave you that B is equal to -7, 8. And they asked you to write this as a column vector, to write OB as a column vector. Now, normally, anytime it's coming from O or the origin, we call them position vectors, right? So the position vector B or OB is going to be where X is going to come up here and your Y goes down here, right? So it basically corresponds if it's a position vector, meaning that if it is I'm given a point and you're looking for O something, then it's going to basically work out to be like this. Now, when it comes to vectors, it comes like you're given the instructions to get from one location. Just a second. All right, so sometimes you might see something like this. So you might see a vector and let's say I'll use back the one that I have here. So let's say they gave you this, and let's say they gave us this point here. So let's say this point is B. Now, the location of B or the address of B is going to be 4, 1, right? So you put the X first and then the Y. Now, if I asked you for the position vector of B, right? The position vector of B is going to be OB is equal to 4. So it comes like you're moving 4 places to the right. So that goes on top. And then you move 1 place up. So the instructions to get us from O to B would be this. Now, normally what might happen is they might give us something like this and then ask you to find, let's say, AB. Right, so they might give us something like this and then ask you, find vector AB. Now, basically, it's like you want to find out the instructions to get us from A to B in that direction. Right, so we're looking for this instructions here. Now, let's say this is my house. And let's say this is Sachin's house. Now, let's say Sachin, I wanted to come by you. And Sachin giving me the instructions and I don't understand how to make it to him. So I'm like, Sachin, I don't know where you live in. I can't find where you live in. So Sachin comes up with a common point that I know and he knows as well. So Sachin is like, all right, miss, you don't understand it this way just so, you know the bus route? And I say, yes, I know the bus route. So what you're gonna do, miss? You're gonna travel from your house to the bus route. Right, so I'm gonna travel from A to O in that direction. And then when you reach to the bus route, you're going to travel from the bus route and he tells me how to get to his house, right? So from there. So I'm going to travel next from O to B. So in order to get from my house to Sachin's house, he gives me the instructions from my house to a common point, which is the bus route. And then from the bus route to the point of where he lives. Now, don't you know the instructions how to get from O to A? We had the instructions how to get from O to A. The instructions to get from O to A was this. But this time we want to go in the opposite direction, which is from A to O. Right? Because it comes like we're starting from my house and we want to end at Sachin's house. So I'm going to start from my house and go the other way around. Anytime you go in an opposite direction, it's going to be minus of the vector. So if from O to A is 3, 4, then in the opposite direction would be the negative of that. And then I'm going to move from O to B, and I know the instructions to get me from O to B. And I'm moving in the same direction of that instructions, so it remains positive. I'm pausing here. All right. Now, when it comes to vectors, you could add and subtract corresponding elements or corresponding numbers. What does that mean? So I have an x value of this vector and an x value of this vector. So we can add those. And I have this y value of this vector and this y value of this vector. So you can add and subtract those. So for this, it's going to be anytime you have something outside of the brackets, whatever is outside, you multiply by everything inside of it. So anytime you just have a negative sign outside of a bracket, we understand that it's -1. So you're going to multiply whatever is outside by each element inside. So it's going to be -1 times 3. So this becomes -3, and -1 times 4. So this becomes -4. Now I could add and subtract the corresponding elements. So I have -4 minus 3 plus 4. -3 plus 4, add and subtract like normal, right? So I have two different signs. So we're going to subtract like normal. 4 minus 3 is 1. And because the bigger number is positive, it will be +1. And then -4, I'm going to add and subtract the y's now. So I have -4 plus 1. Subtract, keep the sign of the bigger number. So -4 plus 1, that's going to be -3. So to get from A to B, this is the instructions here to get me from A to B. So it's like I'm going to go the longer way around in order to figure out what's the shortcut to get me from A to B. Now look at this. I'm starting here. Right, so I'm just going to show you how it lines up with the answer. So I'm starting at A. In order to get to B, I'm going to move one place to the right. So I'll move one place to the right, and I have -3. Then if the y is negative, it means that I have to move down 3 times. So 1, 2, 3. And that's the instructions to get me from A to B. Right? So it's like we're going to take the long route in order to get the instructions for the short route. All right, so in a case like this, they gave us the points A, B, and C. Note how they gave you it. It's going to be in the same order in which it's listed, right? So A is -2, 8, B is 4, 2, and C is 0, 9. M is a midpoint of the line segment AB. Right, so basically, M is the middle of the line AB. It says express each of the following in the form of XY. Now, remember, so they gave us OB. Now I'm gonna add on a little more things so that we are able to get extra practice. Now I know that B is at the location 4, 2. Now if I want OB, it means that this is the instructions as to how to get from O to B, which is from the origin to this point. And we already know that the address or the position lines up to be the same as its vector, right? So if it's like they gave you B and then they asked you to find OB, it's going to line up to be like that. If they gave us, let's say they never asked us for OA, but I'm just doing it to be extra. Right, so if you are given -2, 8, and they asked you to express the following as this, which is a column vector. They could also use the term express as a column vector. OA is going to be -2, 8. If they give us C, they gave us C as 0, 9. Then OC is going to be 0, 9. All right, so pause in here again. Now, for part 2, well, this one, they are asking me for the vector AB. So it's like they want to know the instructions starting from A and ending at B. Now, anytime you have something like this and you know the different position vectors, you could use that in order to help with this. Now remember, a position vector simply means that it's starting from the origin to whatever point that you're moving to. So this comes like, let's say this is A and this is B. It comes like I want to get from A to B, but I don't know the instructions to get me from A to B. So I find a common point that joins the both points, right? And that common point in this case could be the origin. So I could move towards the origin, right? So I'm starting from A, but I'm going to move towards the origin, and then we're moving from the origin to B. Right? Notice the direction. So in order to start from A and end at B, I'm going to go a long way around. So I'm going to move from A to O. So we're moving from A to O. And then, which means we're going to add from O to B. So I don't know what is AO, but we know what is OA. We do know what is OA. And AO is actually the reverse of OA. It's like the opposite direction. And anytime you have an opposite direction, it's going to be the negative of the vector. Right? So AO will be the negative of OA. So it will be negative of that vector, -2, 8. And then we're going to add OB. Now I have OB in the same direction too. OB is 4, 2. Now the reason why AO was negative is because we had OA. So we want to go in the opposite direction of OA, which is from A to O. And in order to show a change in direction with vectors, we use the negative sign. So this becomes, this negative sign will be multiplied by everything inside. Remember, it's like -1 times -2. -1 times -2 will be +2. And -1 times 8 will be -8. Plus 4, 2. So I'm just moving downward here. I'll erase this. Right, so now I could add and subtract our corresponding elements. So this I have 2 plus 4 You add and subtract like normal with respect to the signs. So 4 plus 2, that's 6. Don't forget your rules with integers and positive and negative numbers must also apply. And then I have negative 8 plus 2. Negative 8 plus 2, subtract, keep the sign of the bigger number, so that will be negative 6. So for AB would be 6 negative 6. I'm pausing here. All right, so just to recap where we got up to AB. Now we understood that we knew where OB was and OA was, right? So let's say this was the origin, and let's say this was A and this was B, right? So we basically use this in order to solve for AB. We know what is AB. Now, they told us that M is a midpoint of AB, right? So M is at the middle of AB. And what they asked us to find was OM, right? So O means that you're coming from the same origin all the way to M. So we are trying to find this factor here, which is OM. I'm going to outline it in a thicker red line so you'll see. Right, so we are trying to find OM. Now, anytime they give us something like this, you look around and you see what other direction we could go in order to get to this point. So it's like I want to go from O to M, but I don't know that instruction. So I'm going to go the other way around. So I'm going to go from O to A. So I'm going this way, O to A, right? So OM is going to be the same as going from O to A. And then from A to M. Right? So it's like, if I want to find a particular vector, I could go around it. I could go a longer way around. Now I know what is OA. Remember, OA is negative 2, 8. And AM, we could find out what is AM. Isn't AM half of AB? So in this case, AM is half of AB, half of vector AB. And remember, AB is 6, negative 6. So half of that, anytime you have a number, a letter, a fraction outside of a vector, you could multiply that by everything inside. So it's going to be a half times 6. So half of 6 is 3. And a half times negative 6. A half of negative 6 will be negative 3. So AM is going to be 3, negative 3. I'm pausing here. right? So in order to find OM, so you're starting at O and you're ending at M. So it comes like, I don't understand the instruction to get me from this point to the next point. So I'm going to go a longer way around. I'm going to find an alternative route. So it's like, all right, do you know the bus route? In this case, the bus route is A. So it's like, all right, go from the bus route to yes, the common route is going to be A then. So A is going to be the bus route. So it's going to be from your house, go to the bus route. I said it correctly first time. And then when you reach the bus route, just this time the bus route is A. You're going to go towards M. Right? So we're going to move from my start point to this common point, A. And then from A, you'll move to where the end point that you want to get it to. Now, you are supposed to get information or have information on various factors within in order to help you solve. For example, I know what is OA. OA was negative 2, 8. Now I don't have to make the negative of this because it's in the direction of OA. And then M, AM is half of AB. All right, so we have OA as a negative 2, 8. And then I have AM as 3, negative 3. So in order to find OM, it's going to be the sum of those two vectors. So what we're going to do is we're going to add those two. So we have negative 2, 8 plus 3, negative 3. Remember, you're going to add the corresponding numbers. So the top numbers, you're going to add or subtract them. So that's negative 2 plus 3. Remember your rules for positive and negative numbers. I'll get positive 1. Then for this one, I'll end up with 8 plus negative 3. Anytime you have two different signs back to back, we replace it with a minus sign. So it becomes 8 minus 3, and 8 minus 3 is 5. So this will be 1, 5. So the instructions to get me from A to M is 1, 5. All right, so pausing here again. All right, so for this part number 2, it says using A factors method, show that AC and OB are parallel. Now, basically, for parallel vectors, right? So anytime you have a parallel vector, and we know parallel means that they're running alongside each other, but at equal distance, and they don't ever meet. Now, for vectors to be parallel, it means that one of them is something, some number or some letter times that factor. Right? So anytime you have a number, any number times another, it could be a number or a fraction times it, they are parallel. I'll give you guys an example. Let's say one vector was 4, 2. And another one is 8, 4. Now these two are parallel because if I look at this is actually 2 times this factor. And anytime one vector is something times another, they are parallel, right? So that's something that's like a fact that we must note. So what we're doing is we're basically trying to show that AC, vector AC and vector OB are something times the other, the vector. Now, let's take a look at this. Now, yes, we were not asked to find AC, but in order to help us to find it or to answer this, we need to know what is AC. Now, remember, in order to find out what is AC, it comes like we're going to use what we have. So it comes like I'm going to break this up and go the longer way in order to find it. So I'm going to move from A to O. And then from O to A in order to find it. Sorry, O to C in order to find out the value of this. So we're going from A to O and then from O to C. Now, AO, remember we know OA was -2, 8. We knew that OB was 4, 2. And we know that OC was 0, 9. So to solve this, we're going to find out what is AO, which is the reverse direction of OA. So we're going to use the negative sign to show that it's the reverse. Plus OC, it's going in the same direction as what we know or what was given. So that's going to be plus 0, 9. Now, we can add these in order to figure out what is AC. So this becomes -1 times -2. So this becomes +2. -1 times 8 becomes -8 plus 0, 9. 2 plus 0 is 2. Minus 8 plus 9, subtract the sign of the larger. So that becomes +1. So AC is 2, 1. Now, what they want to know And what they want us to show is that AC and OB are parallel. Remember, OB was 4, 2. And isn't AC, sorry, isn't OB twice AC? Because if I multiply AC, which is 2, 1, by 2, this becomes 2 2s are 4 and 2 1s are 2. So because OB is twice AC, that shows there that they are parallel, right? So parallel vectors, they are some scalar number times the vector. All right, so for this one, they gave us the diagram below shows the triangle OAB. It says OA is equal to R. So instead of giving us the values like this, they gave us a letter to represent it. So in this case, they gave us that OA is equal to R. So it's like the same thing we're doing, except now we don't really have numbers to deal with. We're dealing with the letters that they gave. And then they said that OB, right? So moving from O to B is S. They said, in addition, E is the midpoint of CD, right? So this point E is in the middle of CD, and OC, so from here to here, is 3/4 of OA, and AD is 2/3 of AB. Write in terms of R and S in the simplest form an expression for CD. So we are basically trying to find the instructions as to how to get from C to D. Now, what we want to do is we want to look another way that we could go around. But remember, it must form a triangle. So it comes like we want to start at C. So to move from C to D is like we're starting at C and we're ending at D. So we want to start at the same start point, which is C, and we're going to go another way around. Now you might say, all right, miss, we could probably start from C and go to O and then go this way, but it doesn't form a triangle. It must form a triangle. So the other way I could go is I could start at C and move to A. And then from A, it will take me to D. And that forms an alternative route to get to my endpoint, which is D. Right? So I could, instead of moving from C to D, the alternative route will be to go from C to A, and then from A to D. And that will also take me from C to D. Right? So this is like the alternative route to get to X. All right, so I'm pausing here to check it. Now, I'm going to move from C to A. Now, I don't have values, but I have letters that represent how far I move. And we know in algebra, sometimes letters can be used to replace our numbers. So, and we are accustomed working with letters, so it's going to be the same. Now, we know that OA, the whole of OA is R. But I am not moving from O to A. I'm moving from C to A. Now they told us from O to C was 3/4 of OA. So if that was 3/4, how much will this part be? A quarter, right? Because 3/4 plus a quarter will give me the full length. So from O to C is 3/4 of the line. Then from C to A will be a quarter of the line. So that's a quarter of OA. So for CA, that's going to be a quarter of R. And then AD, they told me that AD is a 2/3 of AB. Now that's all we know right now. But what is AB? So that means we have to figure out what is AB. Right, so I'm going to erase here so you could see it better. Because remember, they want your answer in R and S. They don't want AB in it, so I need to figure out what is AB. So let's look at the bigger triangle. I'm going to figure out what is AB. Right, so let's ignore, let's pretend, or let's ignore this part here. Right, so we're trying to work out what is AB. Now, remember that we know that OA was R. I have it here already. And we know that OB was S. So in order to find AB, I could move, right? So remember, we're starting A and ending B. In order to figure out what is this factor, I'm going to go the long way around. So I'm going to move from A to O. And then from O to B. Now, OA is R. So that means if I'm going from A to O, which is the reverse direction, that's going to be negative R plus OB, I'm moving in the same direction, OB. So that's going to be S. So that means that AB is actually negative R plus S. Pause in here. So remember, CD was equal to CA, which is a half of R, plus 2/3 of AB. And remember, AB was minus R plus S. So 2/3 of AB would be 2/3 of minus R plus S. So what we're going to apply next is just regular algebra and simplifying, right? Because they asked us in its simplest form. So right now we're just basically simplifying here. So we know in algebra, they love us to get rid of brackets first. And in order to get rid of brackets, you multiply whatever is outside by everything inside. So this becomes 2/3 multiplied by negative R. So that will be negative 2/3 R. And then 2/3 by positive S will give me positive 2/3 S. In algebra, it loves organization. So if we have R over here and an R over there, it's not Old MacDonald's farm. So we want to group all of the R's together. Right, so this becomes 1/3 R minus 2/3 R. Right, remember you add and subtract like normal. So it becomes basically like a half minus 2/3. In order to subtract fractions, you have to find the common LCM. My LCM here would be 6. Whatever I do to the bottom to make this 6, I must do to the top. Whatever I do to here to make this 6, I must do to the top. So when I subtract this, I'll end up with 3/6. I'm just subtracting like normal, minus 4/6. We could subtract the numerators. 3 minus 4, that would be minus 1/6. Right? So we add that like normal. Wait, I made a mistake. It's not a half of R. Why do I have a half here? I just have to go back to that point. This is not supposed to be a half. This is a quarter. Right? So remember, CA is a quarter of OA. Why I have a half? Right? So I'm reversing up to that step. Right? So everything else is good, except this is a quarter, not a half. Right? So this is supposed to be a quarter, because remember, OA is R, and if OC is 3/4, then CA would be 1/4. So 3/4 plus 1/4 will make the whole. So this is supposed to be 1/4. I'm sure I said 1/4 and I write the wrong thing in it. All right, so let's go. So same thing. Remember AB, we found AB to be minus R plus S. Expand. So we'll end up with a quarter R, not a half. 2/3 times negative R. So that's going to be negative 2/3 R. 2/3 times S. That's going to be plus 2/3 S. Now we're going to simplify this part. So it's actually a quarter minus 2/3. Find the LCM. My LCM of 4 and 3 is actually 12. Whatever I do to the bottom to make 12, I must do to the top. So it's actually 3/12 minus 4 twos are 8/12. So 3 minus 8 is going to be negative 5/12. So this becomes negative 5/12 R plus the 2/3 S. All right, so I'm just checking over, and it's very important to check over your work because sometimes something like what happened to me actually happens to most of us, right? Where you might copy the wrong thing onto the worksheet and it will throw up the whole work in, right? So we have negative 5/12R plus 2/3 S as the vector, right? So this is my vector CD, right? So that's the answer for CD.